Hey, in this example, you'll be able to sample some sigma notation combined with sum to infinity. So it's two concepts working together, and we're going to take it in three simple, straightforward steps. Step number one, what we're going to do is we are going to write out the series for this particular sigma notation function. Then we're going to deduce the data that we need in order to go to the third step, which is to work out sum to infinity for this particular function. So before we do that, let's take a closer look at sigma notation over here. Sigma notation comes from the Greek word or the Greek letter of S, and here it is a concise notation that represents the summing of a series or a sequence. And right here, what we're summing is the function. And the function here is 4 over 5 to the power of r minus 1. And there are limits. It's from the integer of r equals 2, and in this particular case, all the way to infinity, indefinitely. So let's go through the steps. Step number one, let's write out the series based on this function. And we're going to add up all the values because sigma means the sum of, as I said earlier. So what do we have? Well, the first one is 4/5. So this is going to be 4 over 5, all to the power of r minus 1. The first r is 2, so that will be 2 take away 1. And then we add the next term in the series to the power of the next one, which is 3 take away 1, plus, we're summing because it's sigma notation, 4 minus 1, plus, all the way to infinity. Okay, so how we're going to do this? Well, we've got the series, but we want to fine tune this because we have powers on it. So the first one will be 4/5. So that'll be 4/5 to the power of 2 minus 1, which is 1. So that's going to give us a value of 4 over 5. The next one's going to give us a value of 4 over 5 to the power of 2. 3 minus 1 is 2. So that's going to be the power of 2. And that's going to give us 4 squared. That's 16 all over 25. And the next one over here will be 4 to the power of 3. So that'll be 4/5 to the power of 3. And that's going to equal 4 to the power of 3, which is 64 all over 5 to the power of 3. That's going to give us 125. Okay, so let's write down the series on how it's going to look. So the first one will be the first term, 4 over 5, plus the second term, plus the third term, 64 on 125. And this will go on indefinitely because it is the sum to infinity, and n is approaching infinity. So we have the series, there it is. Now let's deduce the data in step number 2. So what data do we have in order for us to go to step number 3, which is to use this formula down here, sum to infinity. So the data we have, as we identify here, we have the first term, a equals 4/5. Now r, the common ratio, that's going to be this one divided by that one. Well, 4/5 squared divided by 4/5, or alternatively, 16 on 25 divided by 4/5. Well, as you cancel that, turn it upside down, multiply, it's going to give you a grand total of r equals 4/5. So we got a 4/5 and r also is 4/5. Well, what else do we have? Well, we know that we're looking for sum to infinity. That's question mark. How do we know it's infinity? Because of the sigma notation, the infinity sign up there. So let me just put a circle around that. That's our objective. So let's go ahead and drag and drop these values here straight into the sum to infinity formula, which I'm sure many of you have seen before. So let's go ahead and put that in there. So sum to infinity is equal to a, the first term, which is 4/5, all over 1 minus 4/5, because r also is 4/5, as you recall from earlier. There it is again, 4/5. So let's further simplify this. Let's bring it across here. So it's 4/5 That's going to be all over. 1 minus 4/5 is simply, so it's 4/5 divided by 1/5. Well, if we multiply it out over here, that's the same as 4 over 5 times 5 over 1. Remember, when we divide, we multiply by the reciprocal. You already know that. So we have 4 5s are 20, 20 all over 5. So that's going to give us the sum to infinity. Therefore, sum to infinity for this particular function up here with sigma notation gives us a grand total. Adding them up all the way to infinity gives us a value of 20 divided by 5 gives us sum to infinity of 4.